If your team is working in Rust, but you still want to take advantage of our space-proven CCSDS and PUS implementation, you've come to the right place. Let me show you how we have wrapped our C-based CCSDS and PUS implementation called PUSopen into Rust language while respecting the Rust memory model, the concept of borrowing, and the necessary traits. This is how. Rust is designed to overcome the weaknesses of C. Things like using dynamically allocated memory after it has been deallocated, null pointer dereferencing, buffer overflows, things like that. There are many great tutorials on YouTube, I'm sure you know the story. Luckily, PUSopen has been done according to the highest standard for the safety and mission critical systems that are currently known in the industry. We're using MISRA rules, we're using static analysis. The code has been developed in a very basic C, so we never had any integration issues, and we run over 900 tests for every single build. By wrapping PUSopen in Rust, we have added an extra layer of reliability for something that is already developed to the highest standards, so we get the best of the both worlds. So let me now show you how we have created PUSopen wrappers for Rust, the two layers that we have there, and then let's go through the example of communication between the payload and your flight logic. Okay, so let's have a look at our example now. Our example will be the user application code here on the top, then our emulated spacewire driver here at the bottom. It's not really a spacewire driver, you will see it's just a byte stream that we emulate to receive from the real driver. And then PUSopen here in the middle, which is creating the packets on request from the application code and also decoding the packets that were received on the emulated data link. We'll have two threads in the example. The first thread here cyclically will look at whether the PUSopen has received a full packet, CCSDS and PUS, and we'll get the callback once such a full packet is received. And we'll also every second produce a new PUS5 telemetry packet, which we will then retrieve here with the thread 2 and send on the data bus. So the thread 2 here at the bottom will be basically like a data pump between the PUSopen stack and the emulated driver. It will work in both directions, so every second it will look into the driver whether a new bytes were received, and it will feed those bytes into the PUSopen stack. And then also it will look into the PUSopen stack whether there's a new byte stream that it can retrieve from the outgoing buffers and send it out on the data link. So let me now show you the example inside Visual Studio. This is the Rust example inside our examples folder. So we have other examples for Python, for sending raw CCSDS packet, for routing CCSDS packet. So here is the Rust example. And the first thing I want to show you is the build.rs file, where we have this section here, which is calling the tool called bindgen, which is generating out of the C header files of PUSopen. It is generating the equivalent APIs in Rust. First, we give the full set of PUSopen header files to the bindgen, and then we say, okay, these are the public APIs. So all APIs which are starting with these prefixes, which we have ORed here, those are the public APIs, so generate the Rust equivalent of those APIs. And the next thing we ask bindgen is to put everything into the file called bindings.rs. So now let's build the example. So we will generate this lowest layer of the PUSopen wrappers in Rust. Cargo build. It takes a few seconds. The build went okay, so now let's have a look at the generated lowest layer, those unsafe wrappers. Let me find it in the build folder, PUSopen out bindings.rs. Yes, so this is the API, for example, for PUS5TM, which is the API for generating PUS5 telemetry. For those of you who don't know what PUS5 service is, we have another example, another tutorial on this channel, which shows how to use PUS5 in PUSopen. And this is the lowest layer of translating the C APIs into the Rust world. Okay, so this is binding.rs, and that's the lowest, what we call the unsafe layer of PUSopen wrappers in Rust. So let me now open the higher level safe wrappers of PUSopen in Rust. It's called PUSopen.rs. And yeah, this is a good example. So POFrame is the API which is asking PUSopen, hey PUSopen, is there any new byte stream for the packets that the application code asked to generate? So I can take that byte stream and send it out on the data bus. The API takes one custom parameter, which is the buffer that you generate. It's a vector of bytes, and then it returns in the standard Rust way the result. So first of all, like all of the APIs in this wrapper, we are making sure you can use it in the multi-threaded environment. Then, because the buffer that you have provided may have the capacity, but not actually the memory for that capacity allocated, we make sure that we allocate that buffer to its full capacity before we are calling the PUSopen C-based function to actually retrieve that new byte stream that may exist already in the PUSopen stack. We do that using this unsafe keyword, so you don't have to do that inside your code and have like unsafe all over your code. We do that for you. And then once we return back from the C code into the Rust, we check that the C code actually didn't produce the packet that is larger than the buffer that you have created and passed here into this function. We truncate the buffer so you can use standard length function and check how long is the byte stream that we have generated, and then we return the standard Rust result. Okay, so let me now show you in the application code how we use these higher level safe wrappers to call the PUSopen functions. So this is our main function here, thread1 worker, here it is, main function. At the beginning we are initializing the PUSopen library. So we are basically opening the .dll or .so file under Linux. We are doing some initial configuration like setting the API ID. If you are not familiar with the application process ID, we have another video on this channel which explains all of those basic concepts of PUS. Then we are setting up the callback for PUSopen, and that callback called POTM will be used or called whenever we receive the telemetry, the full telemetry packet, and the PUSopen is ready to provide the custom payload of that packet plus some parameters of this packet to your application code. Then we are creating the PUS54 event. So that's one of the PUS objects that we will be using then later in thread 1 to generate the telemetry. And here is the magic of using PUSopen in multi-threaded environment. So as we said, we will be creating two threads. Thread 1, which is cyclically creating the telemetry, TM54, for which we have created the object. And the thread 2, which is basically like a data pump between the SpaceWire driver or our emulated SpaceWire driver and the PUSopen stack. So first of all, we need to take the instance of the PUSopen library and wrap it into what is called the arc. We need to do that because we want to use that same instance of the library in two different threads. The access to the instance is internally protected by the mutex, so it's safe, and we will clone the instance for the thread 1, and we will create the thread 1, and then we will clone it for thread 2, and we will create the thread 2, and then we will wait for both threads to finish. So this is our simple example. The code of the threads is also very simple. The thread 1, which is this one here on the top, basically creating the telemetry and looking whether we have received the full telemetry packets, is exactly doing what we said. It is looking for the packets that were received, and then also every second it is generating telemetry TM54, and we have 10 iterations of this loop, and then there is a second thread which is a data pump between the SpaceWire driver and the PUSopen. So now let's run the example, CLS, and then we do cargo run, and you can see that both threads are running. Thread 1 checking for the incoming packets and also generating the telemetry, and thread 2 being a data pump between the PUSopen stack and the driver. I hope there will be more great languages like Rust. Inside PUSopen we currently have the wrappers for Python, Go and Rust, so pick whichever your team is using. Also, your team may get up to speed with the CCSDS and PUS protocols with our on-site training. If you want to evaluate PUSopen for your space project, simply request it on our website and I will send you your private PUSopen download link. My name is Slavo Petrik, and I look forward to talking to you.